guys see this okay in the back?
Yep.
Yeah.
So we're going to have, I can make it a little bit bigger actually. We're going to have customer, preference, and recommendation. Recommendation V1. Key cloak is in there. That's a Red Hat SSO thing. Don't worry about that for a second. Okay, back to the script. Here we go. So V1 is going to take some load. So on the bottom, I'm going to run a loop that shows me calling into customer. And you can see there's a monotonically increasing integer here that these requests are unique. And you can see also in the log that it's from V1 of our service. Let's say we want to deploy version 2 of the recommendation service. If we look at our Kubernetes YAML here, this is basic Kubernetes deployment. Scripter explains what image I want to use, some of the environment variables, that kind of basic stuff. What we're going to do though is we're going to inject the Istio sidecar proxy into this deployment. We're not going to actually deploy it yet. We're just going to enrich this YAML file with the sidecar. So let's do that. I'm going to use Istio control, which is CLI that comes with Istio. I'm going to do cube inject. Back up. Do cube inject on this deployment, and what that spits out is the deployment YAML that we saw before. So we see the recommendation V2 and whatever it had before. And it adds a new container here. See this entry right here. These are some of the parameters that we're going to pass, but this is the Istio sidecar proxy. And it's configured to talk to the Istio control plane. So when let's see if we can find the image. Prove to you that it really is. Here we go. So here's the image. So there's going to be 2 Docker containers running in this pod. One's the application, one's the sidecar proxy. We haven't deployed anything yet, but what we're going to do is take that YAML and pass it to kubectl create. So we'll do that, or apply. Now when we do that, okay, I'm running the internet off my phone because the Wi-Fi here didn't work out. Now we're going to do get pod. We should see, well, like at the bottom, we can already see that V2 was deployed. We're starting to load balance between V1 and V2. We can see at the top, V2 is actually deployed. These are a bit slow, but that's all right. The point is made. What we just did is we did a deployment to production, but it's taking the V2 load. We don't want that. We don't want to just throw things out into production and impact customers. V2 can have a bug. So what we're going to do is, using Istio, what we should have done beforehand, is use Istio to route all traffic coming in to the cluster when it talks to the recommendation service to go to V1. And you see there's some errors. There's a 500 error. We'll come back to that. I'll tell you what that is and how to work around that. But now we're using Istio. We just created a rule that says anytime you're trying to talk to to recommendations, talk to V1. Let's look at what that rule is. Right here. Whenever we talk to recommendation, route to version 1, route 100% of the traffic to version 1. Now, let's say we do want to release it. We do want to do a canary. We want to do a fraction of traffic, or we want to do very specific fine-grained control over how traffic gets to it. Let's purposely balance between V1 and V2. So using Istio, we're going to create this rule that actually balances 50-50. That makes it the same behavior as what Kubernetes was doing out of the box. But it doesn't have to be 50-50. If we look at that one, we can see that whenever we try to talk to recommendation, that we balance 50-50 across the 2 different versions. And I could change that to 90-10 or 99-1 or whatever and get very fine-grained control over how traffic gets to the recommendation service. The next thing we're going to look at is, well, okay, we have our services running. Let's introduce failures. Let's simulate 503s. So we're going to create a new rule that introduces 503s into the network whenever we try to call the recommendation service. And we can see that here, kind of for a handful of them here. So if we look at that rule real quick, that's very similar, except we add this fault entry into the YAML. And you'll notice the YAML here kind of looks and feels like a Kubernetes YAML. Istio is based on CRDs, custom resource definitions inside of Kubernetes. So we can just basically send this to the Kubernetes API, directly to the Kubernetes API or OpenShift API, and Istio will pick it up and do things. So in this case, we're gonna 20% of the traffic, we're gonna give it a 503, and we see that happen, right? What we can do then, so just imagine there's transient network issues, or whatever. Let's say we don't want that. We don't want to expose that to a customer. What we're going to do is use Istio to implement retries, so automatic retries. So if there's some transient network issue, all right, we'll just retry real quick. And you can see, just basically doing retries, we kind of smooth the traffic out. We don't see those. So we have a failure, retry, that one succeeded, so everything is a little bit smoother. Let's clean that up, because the next demo we don't want that. Deleted the retry, now let's delete the fault injection. Should see things balance back out. Next thing we want to look at is what happens when we introduce latency into the cluster. Let's say we want to do a deployment of a service that introduces a 3-second latency. Obviously, in your code, you're not going to actually do this, but sometimes you introduce bugs or there's latency somewhere in the system, and this is just to illustrate latency. Now, as we see in the bottom, still calling the service, every once in a while, we'll be routed to version 2 that is latent for some reason, 3 seconds worth of latency. And this could bubble up to the customer. If you're trying to go through shopping cart and checkout and do all this stuff, this is killer. You don't want that. So with Istio, what we're going to do is we're going to say, well, we don't want these random amounts of latency, and then we just sit and hang and wait forever. What we're going to do is we're going to install timeouts. We're going to say whenever we call the recommendation service, we'll set a 1-second timeout. Look at that rule. We'll set a 1-second timeout whenever we call recommendation, so that if there's latent services or whatever, then we're not going to just sit around and wait. So we'll create that. On the bottom, you should see we're still going to be load balancing across these services, but when we hit a latent service, we just time out. It should wait at most 1 second. You can kind of see it. Saw it there. You can see it there. Now that's not ideal either, because we don't want to bubble up timeouts to our user, our customers. Let's see what circuit breaking can do for us here. Now, when we do the circuit breaking, what we're going to say is, look at the rule real quick. What we're going to say is, for demo purposes, if we hit one consecutive error, then we will eject that endpoint from our pool of endpoints that we're going to load balance against. So if we have 2, in this case, we have version 2 that's behaving properly and one that's behaving latent. For the one that's behaving latent, if we hit that, we're going to eject that from our load balancing pool. So let's try that. Let's create the circuit breaking policy here. Now at the bottom, what you should see is when we hit those errors, those timeouts, that will eject it, and it'll stay ejected for about 5 seconds. That endpoint will stay ejected for about 5 seconds. Every 5 seconds, with some jitter, it will be allowed back in to the load balancing pool. So you should periodically be able to see this. Yes.
So I understand that it's stopped, right? So it's taken out of the mix for 5 seconds, then it'll send traffic back to that and try it again.
Yep.
So I'm assuming you have different levels of error handling. Did it automatically retry to another pod, or did that go back to the application yet was forced to come second.
Yeah, we should see errors. When it actually hits that timeout, we get it, but then it kicks it out of the load balancing pool. But you're hinting, so how do we solve this? We implement, we specify a retry policy, right?
At the application level.
So you can do it you can do it at the application level, but you can do it in Istio. For this type of retry, you can do that at the Istio level.
So you can do it.
Yep. So we'll do that right now. Just retry, create a retry policy. Now from here on, we shouldn't see. So when it does fail, it gets kicked out of the pool and it retries, and the upstream customer should not see any of those errors.
It's an interesting question. So if we're putting our applications to develop more resilient applications, right?
Yeah.
Now we're taking on some of the responsibility again.
Not responsibility. It's implemented out of process. Still the app developer's responsibility to build resilient applications.
It's configuration.
It's configuration now instead of putting it into application code. And if you have, we can talk more afterward as well about that. Okay, so the last thing, let's see if I can clean up these Istio rules. The last thing I want to show is the security demo. Hopefully this doesn't completely wipe out the stuff that I need. Give me a second here. Come on, internet. It's all right. Oh, that's really slow. Okay, so the last demo that I'm going to do here is we're going to look at, there we go. We're going to look at the mutual TLS. We're going to look at how you create secure communication between services in your cluster. Now, this is absolutely one that could fail pretty badly, so let's see. The first thing we're going to do is we can get our pods. Pod B2. One second. It doesn't matter, but just clean it up to be safe. Okay. First thing we're going to do is we want to capture the traffic. So I want to show you that mutual TLS is actually enabled. We want to capture the traffic between the customer service and the preference service. We're going to capture that traffic. What we're going to use to capture that traffic is the same networking tools you're probably very familiar with. Is we're going to use TCP dump. We need the IP address of the preference pod, and then we'll log into customer, and we'll say, hey, TCP dump, capture all the traffic going to the preference pod. That's what we're going to do. So let's do that. Fingers. Okay, so this is the pod. This is the pod's IP address. This is the preference pod's IP address. This part I already did beforehand, so let me worry about that for a second. Let's capture the traffic. Cross your fingers here. Istio proxy, TCP dump. Okay, let's see what happens. Now we're going to do curl. This is the location that it's running. Don't mind the name of the URL. I was at a conference last week. Send some traffic through. Okay, traffic went through. Now, let's stop that capture. Let's copy that PCAP file over to my machine so we can actually look at it. Okay, that seems to work. Let's open it up. Look at Wireshark real quick. Here's outputs. Actually, the TLS one is there. You're probably going to think that I'm smoking mirrors here, but we get rid of that TLS one. Okay, we'll open up the output one, which should show us the HTTP traffic between customer and between preference. If we click on the traffic, we got the response, we can actually come back in and we can see plain text going over the network, right? Now, what we're going to do is enable mutual TLS. This is a policy, this is a very simple policy in Istio that says for all of the nodes in the service mesh, that on the server side, whenever a connection comes in, it should expect mutual TLS. So it'll send its certificate, but it's expecting the client to send its certificate. The second rule that we're going to look at here is the opposite side of the connection. What is the client going to do? With a destination rule in Istio, we specify how clients connect. With this rule, we're saying as a client, when I make a connection inside the mesh, I'm expecting mutual TLS. So I'll send my certificate, server better send their certificate. So we're gonna create both of those. Create the connection policy. That looks good. Create the destination rule. That looks good. We're gonna do the same thing. We're gonna capture the traffic in between customer and preference, and we're gonna try to look at it. Let's capture that again using TCP dump. All right, it's listening. Let's send some traffic through it. That's good. Stop listening. Let's copy the PCAP file over, which should be output-TLS. If we come back to Wireshark and do open output-TLS, they open. Now we can see the mutual TLS exchange. You can see the handshake that happens to establish TLS, mutual TLS. If we try to look at the responses, we don't have any of the data available to us here, right? This is SSL stuff. This is all encrypted. So by using Istio and these simple configurations, we can make all the traffic in our network secure. I'm severely out of time. The last thing I was going to show is how you can do the same. You can use Istio to. So right now, what we're doing is we're able to verify that the services are allowed to talk with each other. That there's mutual TLS, that are encrypted. Our policies allow the services allowed to talk to each other. But what happens when an end user logs in, and when an end user is asking the service to perform some kind of action, right? You can get into some pretty bad, confused deputy problems when you try to when you get into that situation if you're not verifying authorizations of the user. So in a microservices environment, we typically try to do that with JWT and pass tokens around, this kind of stuff. Istio can validate the JWT token for you. So when you send a request in, comes with the JWT token, Istio can block that traffic if it's not a valid token. You don't have to have special libraries for different frameworks, different languages to actually do that. This can be done outside in the mesh. All right, so I'm completely out of time. So thank you for listening to my part of the presentation. I'll be around for a little bit afterward to answer any questions.